And here we go. Our first function is called the linear function. Okay, identity and linear are the same. So it says identity on the paper. You can also say linear. You do not have to say both, but you need to know they are the same thing. Because sometimes I will refer to it as linear, sometimes I will refer to it as identity. Either word works. So we take a quiz, and I say, which function is this? You can either say identity or you can say linear. All right? Its equation is y equals x. So on your BFF sheet, you're going to write that down, y equals x. And then on your flashcard, wherever you're going to put the equation, you're going to write y equals x. And then the picture is the perfect diagonal right through the origin, just like that. And that's your linear or identity function, y equals x. Every line is going to be a version of that. Now we have the squaring function, which is also called the quadratic. That might be easier for you to remember, but it is the same thing, squaring. And its equation is y equals x squared. So on the BFF sheet, there's a place for you to write the equation. It says y equals, and put x squared. And then your picture, you know this, is a nice little parabola. That is your squaring or quadratic function. So again, if we take a quiz and I draw this picture and say, what's the name of that function? You can say squaring or you can say quadratic. It doesn't matter. Right? What's the next one on our BFF sheet? What's it called? Cubing. There's no other name. That one is just the cubing function. And its equation, you might guess, is y equals x cubed. So we got the squaring, x squared. We got the cubing, x cubed. The curve, and this one, I want you to be a little careful when you draw it. It looks like this. It has a squiggle right there at the origin. So when you draw the first half, you're like drawing a parabola that opens down. But when you get to the top, you switch and draw a parabola that opens up. You see what I'm saying? You do a parabola that opened up or down, and you erase that half and that half. That's your cubic picture. Okay? That one gives us trouble sometimes, so we go through that again. You have trouble drawing that. Think of a parabola that opens down. Think of a parabola that opens up, and then erase half of each one. And that is your cubic function. All right? The reciprocal function. Its equation is y equals 1 over x. The reciprocal, 1 over x. This one, a little bit wild. You're going to have an asymptote on each axis. And then you're going to have a piece of the curve that looks like that. And then the mirror image of it down here. That green right there is a picture of the reciprocal function. So if we take a quiz and we say draw the reciprocal function, that's what you draw. function. And guess what the equation is? Y equals square root x. That's it. That's your square root function equation. And this one you have to draw carefully too. It starts right here at the origin. And then it goes up and out this way, like that. Sometimes I'll see kids try to draw it this way. No, it doesn't go like that. It goes up and out. The exponential is y equals e to the x. Now, I'm perfectly okay if you remembering y equals e to the x because it's the exponential, and that's an e, but that isn't what that e stands for. That e right there is a very special number in mathematics. It's named for Leonard Euler. It's called Euler's constant. Okay, so I just don't want you to think that E stands for exponential. It doesn't, but you can remember it that way. That E is actually a number. It's like pi. It's a very famous math number. And the curve, so when you draw it, this is what you have to draw. All right, there's an asymptote on the x-axis, and there's a dot at 0, 1. This is part of your graph. What I'm doing in red is what you have to put down on your paper. So this way, it gets closer and closer and closer to the asymptote, and this way it shoots up. You might at some point in your life overheard someone say exponential growth. This is exponential growth. It goes really fast. All right, we're half done. Anybody need me to repeat something or got a question about the first 6? So every flashcard has name, equation, picture. Right on the front or the back or however you want to arrange it. But you got to know these things. Okay, let's see the rest of them then. Here we go. What's next? Natural logarithm. You can think of this one as just the logarithm function. You don't have to put natural in there, but you can. The natural logarithm function. Any logarithm function is going to have this shape. So I usually just call it the logarithm function. And its equation is y equals ln x. That's an ln x. Probably studied those last year maybe. Familiar? Maybe? No? Okay. What does a picture look like? Well, there's an asymptote this time on the y-axis, and there's a point on the x-axis at 1, 0. And then it comes up. So these two, the exponential and the logarithm, are kind of like backwards of each other. Here we have the horizontal asymptote at the 0.01. Here we have the vertical asymptote at 0.1. Does that one kind of look like any of the other flashcards you've made already? Yeah, all the time I get students who mix this one up with this one. Anybody remember which one that one was? That I was the square root. Now look, They kind of have the same general shape, but they are different. How are they different? The square root function starts at 0, right? This guy doesn't have a starting spot. This guy goes all the way down, all the way out. So I'm just warning you, they kind of look alike, and it's easy to get it mixed up. All right, sine and cosine. We will spend a lot of time with sine and cosine. The abbreviation for sine is SIN. So your equation that you're going to memorize is y equals SIN x. That is not sin x, that's sine x. Sine, cosine, tangent, that's a sine trig function. The picture looks like this. I need you to come up 1 and down 1. Just label 1 and negative 1 on the flashcard. And then I need you to start at the origin and make a nice little hill that goes up 1. And then a nice little valley that comes down 1. That's enough. In reality, it keeps going forever and ever and ever. But for your purposes, for our purposes, we need to grab 1 hill and 1 valley. Because then we just have another hill and another valley, another hill and another valley. So 1 is enough. That is your sine. Now, cosine, the name of the function is cosine, and the abbreviation is COSX. COS. And that stands for cosine. We do the same thing, up 1 and down 1. Start up here, look where my pen is. Start down. There's your hill. And then you have a valley. And you have another hill. Notice that your sine and your cosine are very similar. What is the difference? Exactly. So you got to remember that sine starts at the origin and cosine starts at the top of the hill at 1. Now, I'll tell you how I remember this, but you figure out your own way. Good Catholic girl, I remember the idea of original sin from religion class. Origin, sign. The sign starts at the origin. It is easy to get these two mixed up because they look so much alike. But somehow you have to keep them straight. All right, 3 more to go. Anybody remember what an absolute value looks like? You studied these last year. Don't tell me you didn't. I know you did. What do they look like? Let me give you a hint. See that letter right there? Absolute value. They look like a V. That is your absolute value function. And your equation is y equals the absolute value of x. At least favorite function of all. The greatest integer. I do not like this. A lot of times we use brackets. Since the greatest integer is also on my calculator, sometimes it looks like this, int x. That's the button I would press if I were doing this on my calculator. The greatest integer function. Now, are we ready to graph it? This one's tricky, right? So we put a dot at the origin. And we color in, straight across one step here, straight across here. Put an open dot there, one over, and then color that in. So you colored in your dot at the origin, you put an open dot, 1 unit over, and you colored in between. Then, right above your open dot, go up 1 and put another closed dot. Open dot to the right of it, 1 unit, and color that in. So you're like, this is sometimes called a step function. You're taking steps. So guess what I do next? Above it, I put 1 unit up, 1 unit above my open dot, I put another closed dot. And then over right 1 from there, I put my open dot and color that in. And of course, it goes both directions. So you don't have to color in a ton of them. I've got 5 of them here. 3 or 4 would probably be fine. That is a greatest integer function. Where we sometimes mess this one up is you need to remember that at the origin is a closed dot. So I always start with my closed dot at the origin and then start drawing from there. I hate that function. I don't hate many things in that function, but that is one that I hate. Alright, and then finally, the logistic function. So, I'm okay with abbreviations. I have no problem with abbreviations. But don't use LOG. Because why? We have logarithms already, right? That could be LOG, and now we have logistic that could be LOG. So don't, if I say name this function, don't write log, either write logarithm or logistic. So that we got those two straight. All right, what does it look like? Oh, what is its equation? Oh, this is a terrible equation. Its equation is y equals 1 over 1 plus e to the negative x. That is the hardest equation. This is the hardest picture. That's the hardest equation. And see that e right there? Guess what that is? That's Euler's constant. Yeah. That's that same e that we had in the exponential. The picture isn't bad. Got an asymptote on the x-axis, and then up 1, you have another horizontal asymptote. So there's 2 horizontal asymptotes. And in reality, they're only 1 unit apart. You got 1 at 0 and 1 at 1. And then, remember your cubing function, that squiggly line? You got one in here, but it's a sideways squiggle. So it looks like that. So the logistic function is capped. It goes forever, but it's capped. Okay? Now, in the next few days, you'll do some practice quizzes. I don't know, 6, 9, I don't know how many we'll do. And then we'll have a quiz next week where you'll have all this memorized, okay? So it's time to start memorizing right now. Quiz will be later in the week, we'll practice, but these have to be memorized, okay? And I would suggest that for what we're about to do, that maybe you just leave them out on your desk for a second, because we're going to do some fun stuff. So let's get our notes out. And let's turn to page 10 of your notes. I know I did a little skipping, but we'll come back and get most of it, not all of it. But I need you to turn to page 10 of your notes. And leave your flashcards out, because we're going to need them, probably. There's no shapes like that. And here's what we're going to do. On page 10, it says, I want you to graph this function. Now you should be like, oh my gosh, this looks hard. It's really very easy. Which of your 12 flashcards is going to help you graph this one? Square root. You know, because it's sitting on your desk right now, that the square root function looks like this. This is a square root problem. Now, what does that 5 do? Anytime you put a number into the problem, it's going to change the original picture somehow. Does anybody happen to remember how a -5 would change that picture? No one?
Would it move to the right 5?
It moves it to the right 5. Very good. I'm going to make a little cheat sheet for you over here. You might want to write this down. If we have this, and I'll just use this square root. If we have this, that's going to go right 5. If we have this, it's going to go left 5. Now, this will be true of any of your flashcards. I am just using the square root example because that's what we have right here. But it wouldn't matter if it was exact squared or any of them. This is what happens. So if the 5 is underneath the square root, if it's attached to the x, you're going to go right or left. That's right or left. If it's -5, it actually goes right. And if it's +5, it actually goes left. Now that is not different than what you already know. Think about when we were graphing our asymptotes yesterday. Where was that asymptote? At -5? Didn't it go left 5? Yeah. Anytime you're inside the parentheses, inside the problem, you're going to do the opposite. So your picture, 1, 2, 3, 4, 5, label that point and draw your curve. That's it. That's all you have to do. This is problem 3A on page 10. Now, what about 3B? Well, 3B is this. What? That's going to be absolute value. So whatever I end up doing to it, it's going to look like this, right? But there's a +1 in there, and that's going to move it. But be careful. Be careful. there's a difference between that and this. Do you see the difference?
Yeah.
When that is attached inside the problem directly to the x, that's left and right. When it's outside the problem, see how it's not in there? When it's outside the problem, it is up and down. So if we have the square root of x plus 1, that's up 1. If we have the square root of x minus 1, it is down 1. And if you're thinking, how come plus is up? I thought it would be opposite. No. It's only opposite when it's inside. Inside parentheses, inside absolute value, inside square root. Then it's opposite. But if it's outside, it's exactly what it says. So this would look like this. And the only thing I ask is that you label your starting point. I'm not making you plot points. I'm not making you have some perfect graph. But I do want you to tell me where you start. Up one. All right. C, kind of went sideways there. C is, well, it's your exponential. So before I figure out what I'm doing with it, I'm gonna remember what my exponential looks like. It has an asymptote here, the point 0, 1, and it goes like this. So, it's easy when you know your functions. I know that's what it's going to look like, so that's why we're going to memorize it. It's going to be 2 days, get them memorized. That's our picture. Now, what am I doing here? Be careful, it's plus 1. Is it going to go up, down, left, or right? Up. If it were going sideways, it would look like this. See how that 1 is hooked to the x? That would take me sideways. This one's going to take me up 1. So you're going to take this picture and lift it up 1. So see that asymptote right there? He's going to go up 1. He's here. See that point? That's 0, 1 in the original. Where's he going to be if I take him up 1?
2.
0, 2. We'll label that. And then I'm drawing my picture. So easy. Alright, what about D? What shape am I dealing with in D? It's the squaring function, which is what shape? Oh my gosh. Ah. How about we just stay? And you forget next time. Wouldn't that be fun? Alright, well we'll pick up here next time. Please do start studying your flashcards.